Okay, 8.3 is angles of depression and elevation. So we are using trig like we learned in 8.1 and 8.2, and really just applying it to word problems. So this video is more just going to serve as a reference for you. We will review all of this together in class, but if you want to go back and review what we did, that's what this video is for. So we're not going to go through everything like we will in class, but I'm just going to do a couple examples for you for your reference. All right, so to start, let's just review what an angle of elevation and an angle of depression is. So angle of elevation is looking up. So that would be this angle right here. It's kind of tough to see. This angle right here, because we have our horizontal line and the angle goes up, right? Okay, angle of depression is going down from the horizontal. Okay, so this is where it does get a little tricky, right? So if I'm looking at this kite or whatever this thing is up here, here's our horizontal line. That's the line of sight, and we're opening down, right, from the horizontal. Angle of elevation is opening up. Angle of depression is opening down. To make it a little bit easier for you guys, we're just going to use this same triangle setup essentially for everything. We'll talk about this in class, but the angle of elevation and the angle of depression are congruent. So regardless of what it says, we can kind of put it in the same place. So let's just look at one example. An airline pilot sights a life raft at a 26-degree angle of depression. Okay, so really, here's our horizontal line, and this right here would be my 26-degree angle of depression. However, we're going to use this triangle that I have here. So if you remember alternate interior angles that we talked about, this 26 up here is going to be the same as this angle down here. So I'm going to just mark this as 26. Okay, and so every angle that we get, we're going to just put in that bottom left corner. All right, the airplane's altitude is 3 kilometers. So if we're thinking altitude, that actually means height, right? That's the distance in the air that it is. So height would be up and down. This is going to be 3 kilometers over here. And we'll talk about some keywords in class. Altitude is one of them. What is the airplane's horizontal distance from the raft? So horizontal is not up and down, it's left and right. So that would be this right here, and that's what we're looking for. So we're going to put that as X. Okay, so now we have a triangle setup, just like what we had in 8.1 and 8.2. So we are going to label our theta, our opposite. So theta is going to go here. That makes this my opposite. This is my 90-degree angle, which makes this my hypotenuse and leaves this as my adjacent. Okay, so H is what we do not need. So if we think about Sohcahtoa, O and A are tangent. Okay, so same setup. Tangent of theta is O over A, and let's fill in what we know. So tangent 26 is 3 over X. And remember, we have the 3 different setups we've talked about in class. So if we put that over 1, we can cross multiply. When we do so, we end up with 3 equals X times tangent of 26. Okay, well, we don't want the X and the tangent together, so I need to divide both sides by the tangent of 26, not just 26. Tangent of 26 is different, right? So I'm going to take 3 divided by that answer. Make sure your calculator is in degrees, and you should get 6.15, and our units are kilometers. All right, let's look at another one. So the meteorologist measures the angle of elevation of a weather balloon is 41 degrees. So again, just for consistency, I'm going to put my 41 in that bottom left corner. That would be the angle of elevation, but whether it's angle of elevation or depression, we're going to put it down in that bottom left corner. A radio signal from the balloon indicates that it is 1,503 meters from his location. To the nearest degree, or sorry, to the nearest meter, how high above the ground is the balloon? So we have to figure out this distance is 1503. Where does it go? All right, so let's look at what we have. We have a meteorologist, so he's a little person down here. The angle of elevation up to the balloon, right? So I don't know how to draw a hot air balloon, but let's just call that what's up there. So if it is 1,503 meters from its location, that's going to be this distance here, right? It doesn't say a horizontal distance or along the ground. It just says from his location, okay? So then how high above the ground, what we're looking for here is this x. That would be the height. Okay, so just like we did in the last one, we're going to label. We have here's theta, which makes this opposite. Here's my right angle, which makes this hypotenuse. And then we're left with adjacent. That has nothing. Okay, so if we look at Sohcahtoa, which one uses O and H? That would be so. So we're going to do sine theta equals O over H. And let's fill in what we've got here. So we have sine of 41 equals x over 1503. And again, if you want to put that over 1, you can. This one's a little bit more straightforward than that last one. We can just cross multiply 1503 times sine 41, and that equals x. So 1503 times sine 41. We should get a pretty big number, and we do. So x is 986.056. So if we're rounding to the nearest meter, it's 0.0, so just 986 meters. That would be our answer. The world's tallest unsupported flagpole is 282 feet tall. I'm going to highlight that. That's probably important. Steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. To the nearest degree, what is the angle of elevation of the sun at the time of the shortest shadow? Okay, so height, right? 280 feet tall. That's going to be over here because that would be the height of the flagpole. The shadow, right? We see shadows along the floor. So the shadow would be down here, 137. Here's my right angle. And then to the nearest degree, what is the angle of elevation to the sun? Well, the sun's up here, right? So this is going to be my theta, angle of elevation. Again, even if that wasn't necessarily how the picture worked out, we are going to put our theta there for consistency. It will work whether it's the angle of depression or the angle of elevation. Okay, so let's label our sides. We have theta. Here's my opposite. Here's my hypotenuse. There's my adjacent. H is off the table, so O and A, again, if we write it out, Sohcahtoa, O and A is that last part, so tangent theta is O over A. So tangent of theta, which we don't know, so let's just put that as x. You could leave it as theta too if you want, but we're more familiar with x, so that might be better. O is 282, and A is 137. Okay, and this is that last type of problem that we talked about in class where here's our unknown. So when that's the case, we need to do the inverse trig function. So I'm going to take the inverse tangent of my ratio. And so on the calculator, again, I just hit second tangent. You should see that tangent with the -1, 282 divided by 137. And to the nearest degree, so I get 64.0887, but nearest degree, we're going to take this, and that is going to just be 64 degrees then is my answer. Okay, so that's it. Like I said, this is more just a refresher. If you need to look back, we will do more of this in class. So you will get a little bit more explanation. We're going to talk about those keywords and a couple more examples. So feel free to look back at this as needed.